Friday night. Peak streaming time. Millions of people are settling in to watch Netflix. Engineers at Netflix have decided this is the perfect time to start crashing servers. On purpose. They have a tool called Chaos Monkey. Some of us techies know about this tool. For Netflix, it randomly terminates production servers during business hours, without warning. While customers are streaming, servers crash, services recover automatically, users keep watching. Nobody watching Netflix notices. Meanwhile, Netflix's competitors, Disney+, HBO Max, Hulu, experience outages that take down their entire platforms for hours. Netflix deliberately crashes its servers and stays online. Their competitors try to keep everything running perfectly, but constantly crash. This is chaos engineering, and it's why Netflix almost never goes down. This is the story of how breaking things on purpose creates resilience, how controlled failure prevents uncontrolled disaster, and why the most conservative approach to infrastructure reliability is deliberately injecting chaos. Welcome back to Season 3 of The Breakdown Economy. I'm Tony. In the last episode, we looked at Spotify's multi-cloud strategy, how they handle infrastructure at massive scale. This episode is about a completely different approach to resilience: chaos engineering. Here's the traditional approach to software reliability. Build your application. Test it in a staging environment. Make sure everything works. Deploy to production. Hope nothing breaks. And when something does break in production, because it always does, you scramble to fix it while customers are affected and the phones are ringing. The failure happens first. Then you discover the problem. Then you fix it. Then you add tests to prevent it from happening again. Reactive. Always playing catch-up. Chaos engineering flips this completely. Instead of waiting for failures to happen in production, you cause failures in production. Deliberately. Regularly. During normal business operations. And here's the key insight that makes this work. If you don't know how your system fails, you don't know if it can recover. You can run all the tests you want in staging. But staging isn't production. Production has different traffic patterns, different data, different failure modes, and different dependencies. Season 2 was full of companies that tested in staging but failed in production. CrowdStrike tested their security update in staging, worked fine, deployed to production, crashed 8.5 million machines. Why? Because production had different Windows configurations, different installed software, different memory patterns, different timing. Staging couldn't predict production failure, because staging isn't production. Netflix's answer: test in production. But test in a controlled way. Don't wait for random failures that might take down your entire platform. Create small, deliberate failures during business hours, when your engineers are watching and not at the beach, when you can observe how systems respond and recover. Controlled failure in testing beats uncontrolled failure in crisis. And when you're Netflix with 270 plus million subscribers globally, streaming billions of hours per month, you can't afford to discover failure modes when customers are watching. You need to find weaknesses before production finds them for you. That's chaos engineering. To understand why Netflix built chaos engineering, you need to understand their infrastructure history. In 2008, Netflix ran entirely on its own data centers, physical servers, hardware they own and manage. Then they make a massive decision: migrate everything to the cloud, specifically Amazon Web Services. This is early AWS, between 2008 and 2010. Cloud computing is new. Most enterprises are skeptical. But Netflix goes all in, and they immediately face a problem. In Netflix's own data centers, servers were reliable. When you own the hardware, you maintain it carefully. Servers rarely fail unexpectedly. Uptime, 99.9% plus. Failures, rare and predictable. Recovery, manual, careful. But in the cloud, it is a completely different model. Cloud servers are disposable. They can be terminated at any time. Spot instances can disappear without warning. Availability zones can have issues. AWS is designed for this. Their architecture assumes servers will fail and replaces them automatically. But Netflix's software wasn't designed for this. From 2008 to 2009, Netflix experienced multiple outages during its cloud migration. Why? Their application architecture assumed servers would stay running. When a critical server failed in the cloud, Netflix's application didn't handle it gracefully. Instead of routing around the failure, the whole system degraded or crashed. Remember the days of that annoying spinning circle? Netflix needed to rebuild its architecture to expect failure. But how do you know if your new architecture actually works? In 2010, Netflix engineers had an idea. If we're building an architecture that's supposed to survive server failures, let's actually test that servers can fail. Not in staging. In production. Right now. So, they built a tool called Chaos Monkey. During normal business hours, Chaos Monkey randomly selects production servers and terminates them. Just kills them. Deliberately. The first time they run Chaos Monkey, Netflix discovers all kinds of problems. Services that couldn't handle server loss, database connections that didn't fail over properly, caching systems that became single points of failure, load balancers that didn't redistribute traffic correctly. But here's what's crucial. They discovered these problems during business hours while engineers were watching with a limited blast radius. Instead of discovering at 3 a.m. on Saturday when the payment system crashes during peak traffic, they discover at 2 p.m. on Tuesday when one service degrades and engineers can immediately see why. Controlled failure reveals weaknesses, then you fix them. Before uncontrolled failure causes a crisis. From 2011 to 2013, Chaos Monkey ran continuously, every weekday, randomly terminating servers. Netflix engineers build resilience into every service. Circuit breakers that stop calling failed services. Automatic retries with exponential backoff. Fallback behaviors when dependencies fail. Health checks and automatic service recovery. Redundancy at every level. Not because they thought these were good ideas theoretically, because Chaos Monkey kept breaking things and forcing them to build better. The results, between 2008 and 2010, before Chaos Monkey, multiple major outages per year. Between 2011 and 2015, Chaos Monkey running. Outages dropped dramatically. From 2015 to 2025, Chaos Engineering expanded. Netflix becomes one of the most reliable streaming platforms on Earth. While competitors like Disney Plus launched with massive outages, HBO Max struggled with reliability, and Paramount Plus and Peacock had regular service disruptions. Netflix just kept streaming. Billions of hours. Millions of concurrent users. Globally. Reliably. Because they'd already found and fixed the failure modes their competitors were discovering in crisis. Chaos Monkey terminates individual servers. That builds resilience at the service level. But Netflix didn't stop there. Netflix runs on AWS across multiple regions globally. US East, US West, Europe, Asia Pacific. Each region has multiple availability zones, redundancy everywhere. If one server fails, traffic routes to another. If one zone fails, another takes over, in theory. But Netflix wanted to know, if an entire AWS region goes offline, can we actually fail over to another region? Not in theory, in practice, right now. Enter Chaos Monkey, terminates individual servers. But Chaos Kong takes down entire AWS regions. They literally simulate an entire AWS region failing. During production, while customers are streaming. All traffic in US East gets rerouted to US West. Databases fail over. Content delivery networks reroute. Customer sessions continue without interruption. Or that's the goal. The first time they ran Chaos Kong, they found all kinds of issues. Database replication was slower than expected. Content that wasn't properly distributed across regions. Services with hard-coded dependencies on specific regions. Load balancing that couldn't handle sudden traffic shifts. But again, they discovered these during controlled tests, not during an actual AWS outage when they'd be scrambling to recover. And when AWS did have actual outages, including the massive October 2025 failure we covered in Season 2, Netflix stayed online. because they'd already practiced failing over multiple times. They knew it worked because they'd tested it in production. Netflix expanded chaos engineering beyond just terminating servers. Latency monkey injects artificial delays to simulate slow networks. Conformity monkey finds services not following best practices. Security monkey finds security vulnerabilities. Janitor monkey cleans up unused resources. Chaos gorilla simulates availability zone failures. Chaos Kong simulates failures across the entire region. Their operations sound like a well-run zoo. Each tool finds different types of weaknesses. Each forces engineers to build more resilience. And critically, all of this runs in production, during business hours, continuously. Back in 2016, Netflix open-sourced Chaos Monkey, making it available to everyone. Now companies across industries use chaos engineering. Amazon, Google, Microsoft, financial services, JP Morgan, Goldman Sachs, retail, Target, Walmart, airlines, United, Southwest, post-meltdown. Even industries where breaking things deliberately sounds insane are adopting chaos engineering. Hospitals are testing electronic health record failover. Airlines are testing reservation system resilience. Nuclear power plants, simulations not actual reactors, are testing safety systems. Because the principle is universal, if you don't test failure modes, production will test them for you at the worst possible time. All right, practical question. Should your company do chaos engineering? And if so, how do you start without causing disasters? First, is chaos engineering right for you? Chaos engineering makes sense when 1. You have production traffic you can't afford to lose. If downtime costs money or user trust, chaos engineering helps prevent it. 2. You have some level of redundancy already. If you're running one server with no backup, chaos engineering just breaks your site. You need basic redundancy first. 3. You have monitoring and observability. You need to see what happens when you inject failures. Without monitoring, chaos engineering is just breaking things blindly. 4. You have the engineering capacity to fix what you discover. Finding problems is only useful if you can fix them. Don't run chaos engineering if you can't act on the findings. Here is how to start. The maturity model. Level 1. Start small, non-critical services. Don't start by crashing your payment system. Start with a non-critical service, something customers won't notice if it fails temporarily. Terminate one server. Observe what happens. Does traffic automatically reroute? Do health checks catch the failure? Does the system recover automatically? Level 2. Expand scope. More services. Once you've proven the concept on non-critical services, expand. Test critical services during low traffic periods. Terminate servers. Inject latency. Simulate dependency failures. Always with monitoring. Always with engineers watching. Always with the ability to stop the experiment if things go wrong. Level 3. Automate. Continuous chaos. This is Netflix level. Chaos runs automatically, every day, continuously finding weaknesses. But you don't start here. You build up to this after months or years of controlled experiments. Level 4. Advanced scenarios. Multi-failure Netflix is running Chaos Kong, simulating entire region failures, testing cascading failures. Multiple things breaking simultaneously. This is for mature infrastructure at a massive scale. Most companies never need this level, but the principle is the same. Gradually increase complexity. Always be learning what breaks and why. Here are some tools to use. Open source. Chaos Monkey, Netflix's original tool. Chaos Toolkit, general purpose. Gremlin, free tier available. Litmus Chaos, Kubernetes focused, commercial. Gremlin, full platform. Chaos Studio, Azure. AWS Fault Injection Simulator. Start with open source. Prove the value. Then consider commercial tools if you need more capabilities. Now we must always take into consideration some critical best practices. 1. Start with a hypothesis. Don't just randomly break things. Have a specific question. If this database fails, will the application fail over correctly? Test that hypothesis. Learn the answer. 2. Define blast radius. Start with small experiments affecting limited services or users. Expand gradually. 3. Have rollback procedures. Always be able to stop the chaos experiment immediately if things go wrong. 4. Run during business hours. Counterintuitive, but critical. You want engineers awake and watching, not scrambling at 3 a.m. And 5. Document and share learnings. Every chaos experiment should teach you something. Document it. Share it. Fix what you discover. Here's what's really radical about chaos engineering. It requires a complete mindset shift. Traditional operations mindset. Our job is to keep everything running perfectly. Failures are bad. We prevent failures through careful planning and testing. And that sounds reasonable. Of course, failures are bad. But it's based on a false assumption that you can prevent all failures through planning. Modern systems are too complex to predict all failure modes. Thousands of services, millions of lines of code, distributed across cloud regions, dependent on dozens of external APIs, handling unpredictable traffic patterns. You can't reason about all the ways this can fail. The combinations are infinite. So chaos engineering says failures will happen. We can't prevent them all. But we can discover them in controlled ways and build resilience. It's not break things and move fast. It's test failures carefully so we don't break catastrophically. Season 2 was full of companies that tried to prevent failures through careful planning, CrowdStrike, careful testing and staging. Still crashed 8.5 million machines in production. Southwest, decades of, if we don't change anything, nothing will break. Then SkySolver crashed at the worst possible time. The prevention mindset. We'll plan carefully to avoid failures. The resilience mindset. We'll test failures so we recover quickly. Guess which one actually works at scale? Netflix doesn't have fewer potential failure points than Disney Plus or HBO Max. They have the same complexity, the same dependencies, the same cloud infrastructure challenges. What's different? Netflix has tested their failure modes. They know their system can recover because they've watched it recover, hundreds of times. Deliberately, competitors discover failure modes during outages. While customers are affected, while engineers are scrambling, Netflix identified the same failure modes during controlled chaos experiments, fixed them, and moved on. And this requires cultural change, not just technical tools. Chaos engineering works when failures are treated as learning opportunities, not blame opportunities. Engineers are encouraged to find weaknesses, not hide them. Leadership supports testing that might cause small problems to prevent big disasters. Teams share learnings openly. Without this culture, chaos engineering becomes just another way to make people nervous about deployments. With this culture, it becomes your competitive advantage. Chaos engineering is counterintuitive, breaking things deliberately to keep them running, but it works. Netflix proves it, AWS uses it, Google, Microsoft, financial services, and airlines, industries where downtime is unacceptable, all use chaos engineering. Because the most conservative approach to reliability is testing that your system can actually survive failure before production tests it for you. In the next episode, distributed databases that actually work. CockroachDB was designed to survive nuclear war. You can literally unplug servers during transactions and nothing breaks. Here's how they built a database with resilience architected in from day one, and when you need that level of fault tolerance versus when PostgreSQL is fine. That's next week on The Breakdown Economy. I'm Tony. Test your failures, build resilience, break things carefully. And remember, if you don't deliberately test how your infrastructure fails, production will test it for you during peak traffic. At 3 a.m., when customers are watching, controlled chaos beats uncontrolled disaster. Every time.